This is updated River Ensemble Outlooks training for both the MMEFS legacy system as well as our new Hydrologic Ensemble Forecasting Service, HEFS. The outline for this MMEFS and HEFS training includes the objective, the official National Weather Service river forecasts, the sources of uncertainty in the river forecast process, the concepts of probabilistic forecasting, our meteorological model-based ensemble forecasting system, followed by the HEFS Hydrologic Ensemble Forecasting Service, changes to the MMEFS HEFS website, the similarities and differences between our official forecast and our MMEFS and HEFS ensemble outlooks, and the similarities and differences for our MMEFS versus the HEFS system, followed by graphics and interpretation of our MMEFS and HEFS system, and finally contacts. The objective of probabilistic forecasting is to help us quantify and convey uncertainty within our NWS river forecasts. Official National Weather Service river forecasts come from the National Weather Service Weather Forecast Office sent to our Advanced Hydrologic Prediction Service, also called AHPS. Most of these river forecasts originate at National Weather Service river forecast centers. These official forecasts can be found on our weather.gov page at water.weather.gov/AHPS. Official National Weather Service forecasts include both past observed precipitation as well as future forecast precipitation as an input into our river forecast process. Currently, rainfall forecasts or quantitative precipitation forecasts, referred to often as QPF, are forecast out 48 hours into the future by the Ohio River Forecast Center, OHRFC, as well as the Southeast River Forecast Center, referred to as SERFC. For the Northeast River Forecast Center, NERFC, and the Middle Atlantic River Forecast Center, MARFC, those future rainfall forecasts go out 72 hours into the future. Sometimes rainfall forecasts for the Ohio River Forecast Center and Southeast River Forecast Center can also be extended to 72 hours when we have high enough confidence. The QPF is generated by the River Forecast Center with human input, combined with our National Weather Prediction Center and the National Blend of Models. The link at the bottom in red is where you can find our national center's rainfall forecasts anytime. The AHPS forecasts involve human forecaster decision-making within the river forecast process. The official forecasts represent the expected outcome given the current state of the hydrologic and atmospheric conditions, as well as taking into account future conditions for rainfall. The rainfall forecast is the human forecaster's representation of the most likely expected outcome of the future rainfall. It is one representation of the possible outcomes. So the forecasters try to take into account all of the uncertainty into that one forecast that you see on the AHPS forecast webpage. There are a number of uncertainties within our river forecasting process. The list here is a series of uncertainties from largest at the top to smallest uncertainties at the bottom. They range from forecast future precipitation to observed precipitation estimates, along with our snow water equivalent or snow water content within our hydrologic model, also precipitation type, temperature estimation, hydrologic model error, evapotranspiration, and even forecaster error. The MMEFS and HEFS system take a number of these things into account. However, with our new HEFS system, there are a couple of notable differences from MMEFS. The first is for forecast future precipitation, the HEFS system tries to bias correct through air distribution the uncertainty within future precipitation. In the future, the HEFS system will also take into account hydrologic model air. Now let's take a look at the concept of probabilistic forecasting for river forecasts. To account for uncertainties in the hydrologic forecast process, we need to input rainfall and temperature scenarios from our weather models into the hydrologic model. Each temperature and rainfall input is run through the hydrologic model to create a hydrograph into the future. From those resulting hydrographs, we can create a distribution of uncertainty into the future. This is risk-based outlooks, and this is really the concept that is used for both the MMEFS and HEFS system. Now let's take a look at the legacy MMEFS system, which stands for the Meteorological Model-Based Ensemble Forecast System, which has been running for almost a decade in most of the eastern U.S. river forecast centers. There were 3 weather model inputs of temperature and precipitation for future outcomes that go into our hydrologic model. Those inputs came from the U.S. Global Ensemble Forecasting System, or GEFS, the North American Ensemble Forecasting System, which combines the GEFS and the Canadian GEM model, that was called the NAEFS system, and finally we had the Short Range Ensemble Forecasting System, or SREF. It should be noted in the updated Ensemble River Outlooks, we are no longer going to have the SREF 1 to 3 day system. The MMEFS system is run 7 days into the future. It only accounts for uncertainties based on non-bias corrected rainfall and temperature inputs from our weather models. The graphics were based on the social science feedback from the Nurture Nature project. Now let's talk about what MMEFS is and what it is not. MMEFS is run by the 4 eastern U.S. river forecast centers, NERFC, MARFC, OHRFC, and Southeast RFC. MMEFS creates a suite of 6 products. It only accounts for uncertainty in precipitation and temperatures, and it is a great tool for what-if scenarios and future planning. It should also be noted that it is automated with no human input during that automation process. MMEFS is not the official NWS forecast. Those are found on water.weather.gov. It does not incorporate future hydrologic model modifications by the human forecaster. It does not account for any uncertainty other than precipitation and temperatures. It does not account for ice, and the precipitation estimates are not bias corrected. In our updated system, MMEFS now has 2 models instead of 3. The first is the GEFS system that we have referred to already. It is 1 model with 21 future scenarios or members. It goes out 7 days and can be run up to 4 times a day. Most river forecast centers run this twice a day, except the Ohio River Forecast Center runs this once a day. There are 6 graphics for each forecast point, and the precipitation and temperatures are not bias corrected. The other model within the MMEFS system is the North American Ensemble Forecasting System. It has 2 models, both the US GFS model as well as the Canadian GEM model. It has 42 members within it. It goes out 7 days into the future, and all of the RFCs run this twice a day. There are 6 graphics for each forecast point, and again, the precipitation and temperatures are not bias corrected. Once again, there are 2 models within the MMEFS system. The first is the GEFS system, which is generally run twice a day at the River Forecast Centers, except the Ohio River Forecast Center, where it is run once a day. The starting time can either be 12Z, 18Z, 0Z, or 6Z. Please refer to your local River Forecast Center to find out the exact run times that are used at that specific River Forecast Center. The graphics are usually available 7 to no later than 9 hours after the beginning of that model cycle time. The North American Ensemble Forecasting System is run at all 4 river forecast centers at both 12 and 0Z, and those graphics are available no later than 10 to 11 hours after the model cycle time. You can also get the latest information on the MMEFS HEFS page, looking for those green banners. In this case, you can see below the purple box, there are green banners for each of the river forecast centers with status and news. If you click on that, that'll give you when the model was run, when the model was completed, and if everything is okay. If you do not see a green banner on the MMEFS HEFS page, then there is a problem. It will show up as red, and you should click on it and read the information. Switching now to our HEFS system, the HEFS system will replace our SREF system on our legacy MMEFS page, as noted here by the red arrow. It is being developed nationwide for both the short and long range outlooks. The short range outlooks go out 10 days and the long range outlooks go out 90 days. The short range outlooks will be available for HEFS from the 4 eastern U.S. river forecast centers on the legacy MMEFS page. The cone of uncertainty will be similar to, but will be created using a different approach. Therefore, the graphics will look a little different between the legacy MMEFS systems of both the NAEFS and GEFS compared to the new HEFS system. The long-range HEFS outlooks will be gradually showing up on our national page. If you go to water.weather.gov, you will see those as long-range outlooks. The capability for the short-range river outlooks of HEFS, or SRO in this case, are not currently available on the national page and will be several years before they are available. Therefore, the Eastern U.S. River Forecast Centers decided to wrap the HEFS short-range outlooks up to 10 days into the future into our legacy MMEFS page. The HEFS system, similar to the MMEFS system, accounts for uncertainty within future temperature and rainfall patterns. But unlike MMEFS, the HEFS system also bias corrects that future temperature and precipitation. In the near future, HEFS will also account for the hydrologic model uncertainty. Now let's take a look at the components that make up the HEFS system. HEFS has the capability to go out beyond 10 days, but we will be focusing here only on the boxes that support the shorter range 10-day HEFS that is available on the MMEFS page. You will note a number of boxes with a red line through it, therefore, and we will not be discussing those today. The inputs to the HEFS system are on the left. The one that is currently being used for the short-range HEFS is the GEFS. It is a reforecast version and should be noted that it lags one version behind the operational GEFS ensemble that is being used for weather modeling. Those inputs from the GEFS reforecast of temperature and precipitation are fed into the meteorological ensemble forecasting processor. This is where the bias correction and spread is done, along with the merging in time and the downscaling to the basin. This data is then fed into the hydrologic model to create the future outcomes of hydrographs, and in essence, the probabilistic distribution. Once again, it should be noted that the current version of the HEFS is not bias correcting the hydrologic model ensembles. From there, graphics are exported to the web for your viewing. Now let's expand on the previous graphic on the HEFS approach. The HEFS system is using the Global Ensemble Forecasting System as a baseline for its precipitation and temperature forcings during the 10-day forecast period. Historical observations and forecasts of precipitation and temperatures are compared to create an air distribution. From there, this results in a bias-corrected mean precipitation and temperature forecast. This process is called the GEFS reforecast. The GEFS reforecast will lag one version behind the operational version of the Global Ensemble Forecasting System's weather model. The MEFP, or the Meteorological Ensemble Forecast Processor, randomly samples the air distribution 60 plus times, constrained by the historical data. From there, this air distribution is different for each 6-hour time step. MEFP, or the Meteorological Ensemble Forecast Processor, uses the Shockey Shuffle, which is really just ranking and stitching together time steps to create a time series. The 60 plus bias corrected time series are then run through the hydrologic model to create hydrologic output traces. Currently, there are no HEFS bias corrections for the hydrology side of things. Only for the precipitation and temperature inputs is there a bias correction. HEFS, unlike MMEFS, has bias-corrected meteorological inputs again of temperature and precipitation, and will in the near future also create hydrologic errors that will be bias-corrected. The goal of the MEFP is to create skillful point forecast at discrete 6-hour time steps and basins into the future. To accomplish this, the point forecasts need to be properly stitched together. Additional detailed training and information on HEFS is available at the following web links. The HEFS version that is available contains over 60 plus members, runs 10 days into the future, is run once a day, contains 4 graphics, and includes bias-corrected precipitation and temperature inputs. The HEFS model is based off the 0Z model cycle and is generally posted to the web page 13 to 15 hours after that model cycle time. If there were any issues with that model run, you will notice the green status bars on the MMEFS HEFS page would turn red. Now let's take a look at the changes to the MMEFS HEFS page. The SREF 3-day MMEFS model has gone away. It is being replaced by the HEFS and goes out 10 days into the future to create better situational awareness. HEFS will only generate 4 graphics while the MMEFS continues to generate 6 graphics. Taking a look at the differences between our official NWS forecast and our river outlooks from the MMEFS and HEFS systems, for observed rainfall, it is quality controlled right before the release of the official forecast, where the rainfall is only quality controlled up to the runtime of the MMEFS and HEFS. Therefore, when you look at MMEFS and HEFS, the last observed rainfall going into that could have been 6 or 12 hours old. Future rainfall in our official forecast generally is 48 to 72 hours into the future, depending on which river forecast center you are working with, where the MMEFS has 7 days of future rainfall and the HEFS has 10 days of future rainfall in it. In terms of releases and operations of flood control projects, The official NWS forecasts use the latest information from the Army Corps of Engineers, where the river outlooks from MMEFS and HEFS are using simulated model operations of those flood projects. In terms of the river model forecaster adjustments, those forecaster adjustments by the human are included in our official National Weather Service forecast, but are not included from the MMEFS and HEFS systems. There is no cone of uncertainty in our official forecast. It is our one best estimate of what we expect to happen, while the MMEFS and HEFS systems do include that cone of uncertainty into the future. Also, forecast updates for our official forecast are done whenever they are needed 24 hours out of the day, where in the MMEFS and HEFS system, they are only updated on a scheduled time. There are some differences between the MMEFS and HEFS systems. For the length of outlooks, the MMEFS system goes 7 days into the future, while the HEFS system goes 10 days into the future. For the number of graphics, the MMEFS has 6, the HEFS has 4. The HEFS will not include the individual trace graphic or the 6-hour rainfall graphic. For weather model inputs into the river model, both the MMEFS and HEFS include temperatures and precipitation, but again, one of the important differences is MMEFS is not bias corrected, where HEFS is bias corrected. For weather model input traces, for the MMEFS system, the GEFS has 21 members, and the NAIFS has 42 members, while the HEFS has 60 plus members. For the outputs from the river model, the GEFS therefore has 21 members, and the NAIFS has 42 members, while the HEFS has 60 plus members. The difference in the HEFS system is some RFCs have 60, others have 65, and others have 68 members. So there is a little bit of difference between each RFC, but they're generally in the range of 60 to 68 members. And the uncertainties accounted for include future temperatures and precipitation in the legacy MMEFS system, as well as in the HEFS system, but in the near future, over the next few years, the HEFS will also include the hydrologic model uncertainties. We are able to take the last two slides that we have been talking about and combine them together to create this nice new slide with 3 columns on it. This slide was provided by the National Weather Service Forecast Office in Wilmington, Ohio. The left column is the official National Weather Service forecasts. The middle column is our legacy MMEFS system, and the right column is our new HEFS system. The bottom line for our official National Weather Service forecasts are: the entire process is humanly touched and quality controlled and assured for both the inputs and the outputs, where the river level outlooks from both the MMEFS and the HEFS are automated and are not humanly quality controlled. Now we are going to switch to the graphics that are available for both the MMEFS and HEFS systems. The main page will show 3 different choices at the top of the image: the GEFS on the left, the North American Ensemble Forecasting System in the middle, and the HEFS system on the right. The NAIFS system will continue to be the default. Again, the NAIFS and the GEFS graphics go out 7 days into the future for planning purposes, and the HEFS system goes out 10 days for planning purposes. The link below the actual graphic here is the link to our MMEFS HEFS page, and that link is not changing. There are also KML files available for download for our partners for situational awareness displays. There is also a table format available as well. This training will also be available anytime in the upper right-hand corner for download for new employees to learn. The RFCs keep updated information on the status of the MMEFS and HEFS in the green area just above the graphic under Status and News. When it is green, everything is on time and good. If it is red, you should click on it and read what the situation is. Which model is currently either running behind or not available. Again, this information is RFC dependent, so you will click RFC by RFC. There is a legend below the graphic for the MMEFS HEFS page to assist in the interpretation of the graphics. Circles mean there is at least a 30% chance of that level occurring. Squares mean there's at least a 70% chance of occurrence. And it is very important to note that the higher category gets preference. So if there is a 30% chance of moderate flooding, it'll show up as a red circle versus if there is a 70% chance of minor flooding and being a square. Therefore, if you have a red circle and an orange square, the red circle with a lower probability but the higher category is what shows on the MMEFS dot plot. Taking a look at the MMEFS graphics, this graphic is the potential river levels. This graphic is showing the potential outcome over the next 7 days. The solid black line is the median of all of the rainfall and temperature inputs. Again, the median means half of the traces are above and half of the traces are below the median. The orange band is the most likely outcome, between 30 and 70% chance of occurrence. The lower side of the orange band is the 70% chance to meet or exceed that level. The upper portion of that orange band is a 30% chance to meet or exceed. The light blue line on the top is the 5% chance to exceed that level, and the bottom darker blue line is the 95% chance to meet or exceed. For the MMEFS individual traces, you can see all of the individual inputs of temperature and precipitation run through our hydrologic model. Again, that solid black line is the median of those rainfall trace inputs. But again, this graphic, unlike the previous, shows all of the individual traces on here. The most likely outcome, again, is in that orange band, which is a 30 to 70% chance range. Another graphic that is available for the MMEFS system is the potential rainfall accumulation over the entire period summed up. This graphic shows each of the individual inputs that goes into our river forecast process for the MMEFS system. Another graphic available in the MMEFS system is the potential rainfall at a 6-hour resolution over the entire 7-day period. You will see each individual rainfall trace that is being input into the MMEFS system here. This is a great graphic if you want to see if all of the models line up with the rainfall events at the same time, or if there's uncertainty both in time and in intensity or magnitude. The RFC has a snow model called Snow 17, which is used with combining precipitation and temperatures to create snow water content. We take the inputs of temperature and precipitation from each of the MMEFS inputs and run that through our Snow 17 model. The output is snow water content traces. It is important to note this graphic is showing snow water content on the ground at each of our forecast basins, melting or growing over time. We also show the potential temperatures at 6-hour time steps over the next 7 days within the MMEFS system. Again, much like the 6-hour precipitation inputs, this graphic is really great to see the confidence over the next 7 days in the temperatures, whether they're all clustered together or whether there's some differences in the upcoming systems where the temperatures are spread apart, either in time or in magnitude. Switching gears now to the HEFS 4 graphics. This first graphic is the potential river levels over the next 10 days. The solid blue line is the median of all of the inputs of both rainfall and temperatures. The blue band is the most likely outcome between the 25 to 75% occurrence range. The top of that blue band is the 25% chance of exceedance, while the bottom is the 75% chance of exceedance. It should be noted, in the MMEFS graphics, the orange band was the 30 to 70% range. In the new HEFS graphics, it's the 25 to 75% range. This change occurred because of updated information from social scientists. The green and orange bands have lower chances of occurrence, but still, they could occur. Another graphic available in the HEFS graphics, similar to the MMEFS, is the accumulated 10-day precipitation band. You will see it grows over time, and when you see big jumps, that is when you can see an event occurring. Another graphic is the 10-day snow water content. This is the amount of snow in the model that is building or subtracting over time based on warming and cooling periods. The last graphic that is available is the 10-day surface air temperatures. Let's take a look at how we interpret the MMEFS and HEFS river outlooks. Looking at how to interpret the HEFS 10-day river level probabilities graphic, looking at that blue cone of uncertainty, the bottom of that plume is 75% probability of exceeding. The top of it is a 25% probability of exceeding. So given that, it looks like there's about a 35% chance of reaching minor flood level, as denoted in the orange dashed line. Moving further up for the moderate level, it appears that there's about a 20% probability of reaching the moderate flood level. And moving further up, there's less than a 10% probability of reaching major flood level a few days from the issuance time. This graphic contains both high uncertainty and lower confidence, as well as lower uncertainty and higher confidence. In the first future event, you see the wide range in the cone from well below minor flood level to well into major flood level. That means that there is a lot of uncertainty in that event with lower confidence of what actually will happen. Further in time out into the future in this graphic, you will see a much tighter range, implying less uncertainty and higher confidence. These new graphics were developed by the Middle Atlantic River Forecast Center based on the Nurture Nature Social Science study. Switching now to the MMEFS interpretation, the most likely outcome is in the orange band, and in this case would be in the moderate flood level. In this case for MMEFS, there's about a 95% chance of reaching minor flood level, about a 70% chance of reaching moderate flood level, and less than a 5% chance of reaching major flood level. In this MMEFS graphic, what it shows is that uncertainty changes over time. In this case, the spread is larger earlier on and then actually contracts a little bit with less uncertainty near the peak of this event, meaning that the confidence is medium to high of a minor to moderate flood event. In cases where the range is large, that means uncertainty is large and confidence is lower. In cases where the range is small, uncertainty is small and the confidence is higher. In general, bigger, slower rivers have higher confidence and less spread, while smaller streams, creeks, have less confidence with more spread. Finally, if you have questions about the legacy MMEFS system or the new HEFS system, you can contact your nearest River Forecast Center. The contacts for each of the River Forecast Centers are here, but if you do not know who to contact or need additional information, you can send an email to james.nowell@noaa.gov and he will pass the information on to the Servicing River Forecast Center.